In this video, we're going to start the basics for counting, which is going to help us later on to figure out basic probabilities and everything. So let's start this off by learning how to count properly. And I'm not talking about using your fingers or anything. What I'm talking about is, let's say you go to a sandwich shop. All right, so we're going to go make a sandwich. And at this sandwich shop, you start off with determining what type of bread you'd like. All right. Now, this is not a very fancy one. There's only two types of bread. We have wheat bread, and then we have traditional white bread. And then the next thing would be the type of meat you want. So there are different types. You can have like an Italian. Obviously, I don't know how to spell that. All right. You can get tuna. You can get roast beef. Or let's see, what's another one we could get? How about a club? All right, so those are the types. Then you pick what type of veggies you would like. All right, and like I said, not a lot of veggies here. We have onion. We have lettuce, tomato, and one more veggie. Give us one more veggie. How about pickles? I love pickles. All right. Finally, we have our sauce. So you can get mayo, mustard, honey mustard, and we're going to say that's it for now. All right. So the question becomes, how many sandwiches can we make? All right. So, like, for example, somebody can come in and say, well, I would like wheat bread, tuna, lettuce, pickles, and add a little bit extra mayo. All right. That would be one sub right there, or one sandwich. Then the other option, somebody can come in and say, well, I want white bread with no meat. Give me all the vegetables and some honey mustard. That's another sub. Okay. So, how many can we actually create? Well, in order for us to calculate that, we're going to need something called the fundamental counting principle. So let me write this out. All right, so I didn't exactly write it out. I copy and pasted it from our text. But here's how this works. If you can choose one item from a group of M items, so what they're saying here is, in the first option, you can select one of them, and then you select another item from another group, then the total number is going to be M times N. In other words, you take however many items are in the first group and you multiply them by however many items are in the second group. Now, if we do that up above, notice here we have two types of bread times 1, 2, 3, 4 types of sandwiches or 4 types of meat times 1, 2, 3, 4 veggies and 3 sauces. So all we have to do is take 2 times 4 times 4 times 3, and that gives us a total of 96 different sandwiches. And this is how we count. This is how we figure out how many options we have. Now, sometimes it's very straightforward like this. All right, here's another example. How many different PA license plates can we have? All right, now we will exclude vanity plates. All right. So vanity plates are the ones that say something interesting on the back, or, I don't know, like cool dude or something like that. Don't ask me. But anyways, so how many different license plates can we have? Well, if we think about what a license plate looks like, all PA license plates have 3 letters and then a hyphen, and then it's separated by 4 numbers. Now, there are no restrictions or anything like that. So the first spot has a total of 26 options because there's 26 letters in the alphabet. Same thing for the second spot and the third spot. So far, just for the letters, we have 26 times 26 times 26. Now let's worry about the numbers. Well, the numbers can be 0 through 9. Well, that's a total of 10 numbers. So we have, for the numbers, we have 10, 10, 10, and 10. So we need to multiply 26 times 26 times 26 times 10 times 10 times 10. And that turns out to be 175,760,000 different plates. So, will we ever exhaust the possible number of plates that we can have in Pennsylvania? As long as the population doesn't get above 175,760,000 different plates, we'll never ever exhaust that. And just to give you an idea, the total population of the United States is about 275 million right now. So this is the entire country. We are just one state out of that. So the answer is no. We're not going to ever exhaust the number of license plates we can have. Now, here are 2 examples we just covered where, although they were vastly different, they had the same exact structure in terms of calculating the actual result. All right. The sandwich, notice we had 1, 2, 3, 4 different categories where we just counted each individual category and multiplied everything together. In the second example, we did the same exact thing. We had 1, 2, 3 possible slots or 3 possible positions for letters. And then we had 1, 2, 3, 4 possible positions for the numbers. But then we just multiplied everything together. Sometimes we can visually represent this. All right. So your book does a really good example of this. So I'm gonna steal their example. Well, I'm gonna just steal their picture. But here's basically what the example is. You have 2 pairs of pants. All right, blue or black. You will have 3 shirts. All right, and we'll say on my screen it kind of looks cream, yellow, and blue. And then you have 2 types of shoes, black or red. Show all the possible combinations, or how about this? Show all the possible outfits you can create. All right. So one way you could approach this is you could just try to start to write everything out. Like, okay, well, I have my pants are first, and I'm going to use the cream shirt, black shoes. All right, that's one. Actually, let's use the blue jeans. Blue pants, cream shirt, black shoes. Or blue pants, yellow shirt, black shoes. Or blue pants, blue shirt, black shoes. Or blue pants, cream shirt, red shoes. All right. And you could just muscle your way through this. All right. We call this the method of exhaustion. Because it is exhausting to do this. It's not fun at all. Another way, a better way to approach the same exact problem is called a tree diagram. All right. So how a tree diagram works is you start off with the person. So this is going to be us. And put a little happy face. There we go. And the first thing we know is we have pants. Blue or black. And then the next option would be shirts. Well, if we stem off our blue pants, we have 3 different types of shirts. We have cream, yellow, and then blue. Same exact thing with our black pants. Cream, yellow, blue. And then once we've picked out our pants and our shirt, now we have our shoes. Black or red. And hopefully from here, you can see how much more organized this is, how much easier it is to flow. And then you can just count at the very end how many of these options you actually have. So it's really not that bad when you look at it like this. Like, for example, one day I can wake up, wear black pants, blue shirt, black shoes. So there's one outfit right there. All right. And then you can just keep doing this. Now, your book has a really nice picture of this that I'm going to show you. All right. And here it is right here. So there you go. It's the same exact thing as what I did. Oh, I forgot the shoes. I didn't include the shoes in the picture. Let's get those shoes in there. Where are the shoes at? Maybe it's over here on this page. Ah, there it is. I had the wrong picture. That's why. So we're going to fix this real fast. Get rid of that. Here we go. So this is exactly what we call a tree diagram. You could just start with what you have and then create branches of what you want to wear that day. And this is why I think dads dress the way they do. Because they think about this. There are 1, 2, 3, 4, 5, 6 total outfits here. That's almost a week's worth of clothing, if you think about it. Okay, the last example I'm going to do for us is going to be one where there are like restrictions, okay? Just so you could see how this works. So, we're going to talk about telephone numbers. Now, if you think about what a telephone number has, all right? First, there are 3 numbers out front, which is going to be the area code. Okay? Let me write that a little cleaner. Then you have the local telephone number itself. So there are 3 digits for the first and then 4 digits for the second. All right? So this is going to be the local telephone number. And to be honest with you, these 3 numbers up here, they mean something. And then the last 4 numbers, they mean something as well. So it's not like Numbers are just randomly generated. I mean, there's a purpose for all of this, all right? Now, there are some restrictions though. For example, with area codes, this first number right here cannot be 0 or 1. You'll never ever see an area code where the first number is 0 or 1. Also, with a local telephone number, this number cannot be 0 or 1 also. All right? So right there are the restrictions. All right? Now, in the other slots, where I'm highlighting in purple, all right, they can be any number we want between 0 and 9. So that's okay. So when we go ahead and we go to calculate, how many phone numbers there are, with the restrictions in place, all you have to do is think about the fundamental counting principle, all right? Here's the area code. We'll do this first. Now we know the first digit cannot be 0 or 1. So traditionally, there would be 10 possible numbers, but I'm not allowed to use 0. I'm not allowed to use 1. So now there are only 8 possible numbers for the first position. Then for the other two positions, I can choose between 0 and 9, which is a total of 10 numbers. Now, for the local telephone number itself, we have the 3 digits up front and then the 4 digits behind it. The very first number cannot be 0 or 1, so there's only 8 possible numbers to pick from there. And then finally, all these numbers can be anywhere between 0 and 9, so a possible 10. So all we have to do here is multiply 8 times 10 times 10 times 8 times 10 times 10 times 10 times 10 times 10 times 10 again. Another way to think about this would be 8 to the second times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. And that would be a total of 6,400,000,000 telephone numbers. So if everybody in the entire world had their own phone number, we would run out of phone numbers. Because I think there's like 7 billion people, or like 7.5 billion people on planet Earth. The United States, however, we're never going to run out of phone numbers. In fact, what ends up happening is when you die, your phone number is basically put at the bottom of the list, and it is recycled like 100 years later or something like that. So they end up recycling numbers. There are other numbers that are special. Companies pay for their own number, stuff like that. But this is the fundamental counting principle in all of its glory. So I will see you in the next video where we talk about counting techniques.